tree is a very, very, very important structure in data structures and algorithms for the complex applications. It's mostly used in algorithmic stuff like data compression, data translation, tidying, in many other applications. Many like on the web, even trees are used to create the HTML elements structure. Trees used there. It has countless applications, and this is a hierarchical structure and must have a root node, just like any other tree on earth. Tree should be understood the way that we see the tree in the real world. So, for example, this is the ground. See on the right side, this is the ground. From the ground, this root starts. This is the first node. Okay, this is the root. Then it has a stem and branches. So our tree, it can go up till here and then start from here. But this is kind of a tree which has all the branches starting. So any node is connected to the next node, just like a linked list. Okay? We did understand singly, doubly, and circular as well. There is no circular concept here. You can build it. It's up to you, up to your requirement. This is one list starting from here, going here. This is the second list going here on this direction. This is just one list root to directly last node in this branch. In this branch, we're going till here. In this branch, we are going from root till here. So what are these? What are these boxes? These are nodes. These are small structures that we did study in our linked list chapters. And any node that is at the end of a branch, this one, for example, this one, and this one, these are called the leaf nodes. Last nodes in a structure, tree structure, are called last nodes, end nodes. And the one that is here, the beginning point, is always a root. So most of the examples that you see on somewhere against the tree, they're shown upside down. To make more sense out of it, I have drawn them from ground to top, from bottom to top, so that you understand root starts here, root starts here. Okay? Just give me a second. Root starts here, then it has branches, and every branch contains nodes, and every node can point to yet another node or multiple nodes. This is a common tree, common structure. You can see it here as well in this example. This one also shows the same structure that is here on this side, on the right side. On the left side, it's more expressive. It has the words node, and this is child node, child node, child node. And this one, the last one, is just node because it's a leaf. Leaf is the last node. Okay? And these grayed ones. These gray are in here, the circular, these circles. Okay? Not circular, but circles, what I'm saying. These circles, these are also leaf nodes in here. And the same structures in the boxes on the left side. There's nothing to worry about. It's pretty much understandable. I hope you understand the trees, and we will see examples as well. There are types of trees, and the binary tree, bi means die or bi means two. So binary means two. Binary means which has two nodes. Each node has two nodes. That is called a binary tree. So this is our binary tree. Every node has two nodes. Root node has two nodes. These are the two nodes. Okay? Root has these two nodes. And these two nodes, each amongst them have two nodes. Each have two nodes. So it's really simple to understand. The structure is going to point to the next one and next two, for example, or node 1 in node 2. So that is going to become a tree. A simple structure is going to become a tree. And in this case, on the right side, you can see in here, we have the trinary tree. Trinary means the one that has three states, or you can say three options, or three faces, or three directions, is called trinary. Okay? Compared to binary, which is like binary number system, for example, we say it has only two directions. Either it's 0 or 1. Trinary has 0, 1, 2. So this is a trinary tree. This one node actually points to three different nodes here. Okay. Then each node is pointing to three different nodes, which are actually leaves because they are at the end in here, in this example. These are three leaves. They are still nodes, but they are called leaves when you're talking in terms of data structures. Okay. I hope you did understand till here. Now, the other structure that we have is n-ary trees. N actually, it means that it can be any number. So root can point to as many nodes it wants to point, either 1 or 2 or 3 or 4 or 5, whatever number each node can point to. Implementation is little different than the ones that we do with the limited number of nodes that we create under one node. The child nodes that we create, these are the child nodes. These two are child nodes of the root. These two are child node of this one. So these, whenever we have a number already specified, we have binary and trinary, commonly known as the trees. If they go beyond the 2 and 3, then we call it n-ary trees. Okay, n-ary trees you can say, because this is not usually pronounced. If you want to pronounce it, fine enough. So it's n-ary trees. Okay. So n-ary trees means the n stands for the number that is dynamic, that is not predefined. You do not determine the number before creating the tree. You have the structure which allows the dynamic allocation of the same structure at runtime for the children. The structure, I'll repeat, the structure that allows at the runtime the dynamic allocation of as many children the program requires of the same structure. I hope it does make sense. So we are going to see now different kind of examples of the trees.